Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 24th sum. Already in the last videos, I have uploaded till 23rd sum solution. So please do check it. Now we can start with the 24th sum. So determine if f defined by f of x equal to x square sine 1 by x if x is not equal to 0. Okay, if a input is not equal to 0, then we have to use the first function. 0 if x equal to 0, that means if input is exactly 0, the result is also 0, is a continuous function. So they're asking us to determine this f of x is a continuous function. Okay, so at what point we have to determine whether the f of x is continuous or not. They didn't mention, so we have to understand throughout the real line the question is demanding us to determine the f of x is a continuous function. So let me take a real line. Okay, so minus infinity to infinite. Now using the given condition, I'm going to if condition, I'm going to break the real line at x equal to 0. Okay, now we can see the two intervals over here. This interval is what? If x is less than 0 means all the values we have here. Okay, if x is greater than 0 means we have such type of values in this particular interval. Okay, so but we can understand that this interval as well as the second interval, both are x is not equal to 0 only. So as per the given condition, if x is less than 0, do we have a different function? No. If x is greater than 0, we have a different function? No. We have only if x is not equal to 0. So based on the given only, we should have the cases. Here, if x is not equal to 0 means both the intervals come, we can together find out. Okay, so we don't need to have a different cases here. Now if x is exactly 0. Okay, so in the case 1, if x is exactly 0, whether f of x is continuous or not, we are going to check. If x is not equal to 0, both the intervals together we are going to include it. Okay, that is case 2. If x is not equal to 0, that is going to be case 2. So only we are going to have a two cases to determine the continuous of the given f of x. And to check the continuity for the any function, always do remember we need three things. What are those? Suppose if I am checking for the at x equal to 0, the continuity means I need f of 0 value, left hand limit, right hand limit. Okay, if all the three values are same, then we can say that f of x is continuous. Okay, so this is how we need to proceed. Now let's start with case 1. If x is exactly 0. Okay, if x is exactly 0, from the given, what is the suitable function? Second function. So f of x equal to 0, then what is the input? Even if the input 0 means answer is going to be 0 only. Okay, so now uh, f of 0 we found. Now we need left hand limit, right hand limit, right? Now left hand limit and for right hand limit, do we have a different functions here? No, only one function only we have. And here you can notice that x square sine 1 by x. So sine 1 by x we have. So what I'm going to do is, we know the range for the sine functions, right? So using that, I'm going to get the left hand limit, right hand limit together. Okay, so what is the minimum and maximum values for the sine function? Minus 1 to 1. So minus 1 less than or equal to, what is the sine function? We have sine 1 by x. No, so sine 1 by x less than or equal to 1. Okay, now what I'm going to do is, with the sine 1 by x, we have one more function that is multiplying, that is x square. Throughout the inequality, I'm going to multiply the x square. Okay, so my minus 1 into x square, that is going to be minus x square less than or equal to x square sine 1 by x less than or equal to x square. Okay, so now I'm going to apply the limit. What is the limit that we have? Limit x is approaching to 0. I'm going to apply through the inequality. So limit x is approaching to 0. So here minus x square less than or equal to limit x is approaching to 0, x square sine 1 by x. And here also limit x is approaching to 0, x square. Now let's apply the limit. What happens here? If you apply the limit minus 0 square, which is 0, less than or equal to limit x is approaching to 0, x square sine 1 by x less than or equal to, here also as well, if you apply the limit 0. So what we can say from this, the left hand limit, that is limit x is approaching to 0, x square sine 1 by x, what is the value that we are getting? The 0. Same way, right hand limit, limit x is approaching to 0 from right side, x square sine 1 by x, those values also it's 0. So what we can say from these two, the left hand limit and right hand limit and f of 0, we can say that all the values are same. F of 0, left hand limit and right hand limits are same. We can say that the given f of x is continuous at x equal to 0. Okay, if x is not equal to 0, how, whether it's a continuous, we will see now. Okay, So now case 2. Okay, I need to write the conclusion. F of x is continuous if x is exactly 0. Now in case 2, what is that? If a condition, if x is not equal to 0. In a real line, if x is not equal to 0, how many real values are there? Infinite real values? No. So let c be the any real value, at the same time c is not equal to 0. Okay, so first let's find f of c value. So what is the f of c here? If c is not equal to 0, a suitable function is first one, that is x square into sine 1 by x. That means c square into sine 1 by c. Okay, so to check the continuity for the any point, I already told we need three things, that is at the point value and left hand limit and right hand limit is required. Now we found for the f of c. Now left hand limit, right hand limit we need to find out. Okay, and for left hand side and for the right side, the closed values are also not equal to 0 only. Okay, so together itself we can find out. Now limit x is approaching to c, f of x. So suitable function, I will replace now. What is a suitable function? X square sine 1 by x. Now apply the limit c square sine 1 by c. So now we can see f of c value and limit x is approaching to c, both are same. So we can say that f of x is continuous if x is not equal to 0. Now from both the cases we can conclude that if x is exactly 0 also function is continuous. If x is not equal to 0 also function is continuous. So from both the cases we can say that f of x is continuous for all the real values. For all real values. So that's all the solution for the 24th sum. Thanks for watching and please do subscribe. Thank you.